In sub-Saharan Africa, agriculture covers about 12.6% of the total land under cultivation, dominated by small-scale farmers. Agriculture plays a vital role in Kenya's economy, directly contributing 22 to 30% of its gross domestic product (GDP) and employing over 40% of the total population. The region currently grapples with acute food and nutrition insecurity, driven by population increase, unpredictable weather patterns, and declining soil fertility, attributed to continuous monocropping and low fertilizer use per unit of harvested area, often resulting in negative nutrient balances. To meet rising food demand driven by population growth, farmers in sub-Saharan Africa must intensify fertilizer use, particularly nitrogen, which crops need in large quantities to produce more food on existing agricultural land.
First, our soils are very degraded. We went back to subsistent farming. Subsistent farming means that you grow your crops with minimum input. So we've been mining nutrients year after year for the last 60 years, and that has resulted to soil degradation. So we are having a lot of nutrients that are lacking in the soil, and therefore we need to replenish them.
However, unsustainable fertilizer increase can contribute to greenhouse gas emissions, which are responsible for global warming and climate change.
As we continue to farm, as we continue to produce more food, and as we continue to increase the amount of fertilizer that we put in the soil, there is bound to be an increase in these emissions in the atmosphere.
When nitrogen is not fully utilized by crops, a potent greenhouse gas, known as nitrous oxide, escapes into the atmosphere.
With this increase, we will see global warming, erratic rainfall, or rising temperature changes. And this is detrimental, especially for sub-Saharan Africa, where most of the agriculture is rain-fed. So with climate change, they cannot predict, for example, when to plant. They cannot predict when to harvest. So it's important for us to measure these emissions and to know how to reduce the emissions and at the same time increase the yield.
A multidisciplinary collaboration team involving researchers from Swiss Data Science Center, ETH Zurich, University of Eldoret, International Livestock Research Institute, and University of Bern sought to generate field-based evidences of N2O emissions from agricultural soils, which is key in supporting efficient and sustainable agricultural production, and also addresses the issue of limited N2O data in SSA.
We decided to do the measurements in Kenya because in this region we find that most of the studies that are conducted come from this region. So we want to build on the knowledge. We also wanted to measure for a whole year so that we can capture the dry and wet seasons, so that we can understand these emissions, how they behave under different environmental conditions.
They compared maize and potato plots, each receiving 50 and 100 kilograms of nitrogen per hectare. The researchers used automated static chambers placed directly on the ground to measure nitrous oxide fluxes coming out of the soil.
In addition, the study assessed the effect of increased nitrogen fertilizer rates, that is from 0 to 125 kg per hectare, on the soil plant atmosphere continuum. And then we collected data on soil mineral and concentration at different soil depths and relevant nitrogen use efficiency indices.
After collecting and analyzing the data, the researchers shared their findings with the farmers and other stakeholders at a dissemination workshop at the university.
The study demonstrated that emissions were not constant, as the fluxes increased sharply after each fertilizer application, particularly following rainfall events. In addition, higher nitrogen application generally led to more nitrous oxide emissions. The annual cumulative N2O emissions from the 100 kg N rate was almost double than that of 50 kg N rate. We also observe differences between maize and potato systems, showing that crop type matters. Further, the study demonstrated that increasing nitrogen fertilizer application rates elevated the soil mineral N concentration, especially on the surface horizon. In addition, the study determined that increasing N application rates to between 75 kg and 100 kg N per hectare will not only increase maize grain yield, dry matter and N uptake, but also optimize the nitrogen use efficiency.
One of the key takeaways from the workshop was the importance of nitrogen management for efficient, economic and sustainable crop production, a point that different stakeholders emphasized.
Siku ya leo tumepata mafundisho kuhusu mambo na mchanga. Imekuwa ya manufaa kwangu kwamba mbolea tunayotumia kupanda mimea iko na kiwango chake ambacho hakistahili ipite ama ipungue.
Mimi mkulima wa mahindi, na mahindi iko na challenge mingi, na nashukuru Mungu kwa sababu leo nimejifunza maneno ambaye naweza kunisaidia kwa vile matumizi ya mbolea, vile mimi naweka mara ngapi na haya yote ambaye tumesoma siku ya leo.
The conversation was not just about emissions. It was about costs, yields, soil health and long-term sustainability.
Nilikuwa nauliza hiyo mambo ya top dressing. Kuna sia na kuna urea. Sasa urea tuliambiwa hapo nyuma inaharibu mchanga. Sasa sijui kama ni ukweli.
The goal is not to reduce fertilizer use blindly, but to use it smarter.
And the whole interest of the whole agricultural sector is to ensure that it gives money to everybody.
Increasing fertilizer use, especially nitrogen, is essential for food security in Kenya, but smarter nitrogen management is critical in reducing greenhouse gas emissions and supporting sustainable agricultural production. Soil testing is a crucial tool in sustainable nutrient and soil management because it provides information on fertility status necessary for decision-making purposes such as fertilizer application. It also tracks fertility changes over time.
Kama mchanga wangu wakati last time ilikuwa na acid, nikapatiwa formulation ya kuchanganya na mbolea ndio uweze kumaliza hiyo acidity. And then pia nitrogen ilikuwa chini, nikapatiwa recommendation ya kutumia mbolea yenye itapandisha hiyo nitrogen ikuje to the optimum level ya kupanda viazi.
Kabla sijafanya soil testing, masao kwa eka moja nilikuwa napata, kama mahindi nilikuwa napata kunia 15, 12, 10 mpaka 17 hivi. Lakini baada ya kuimprove mchanga soil, kureduce pH ya acid, so nimeweza kupata kuanzia kunia 25 mpaka 38.
Sustainable agricultural production entails feeding today's population without harming tomorrow's. By working together, scientists, farmers, research institutions, and policymakers, we can grow more food, improve livelihoods, and protect the climate at the same time.